December 19th, 1942. Longstop Hill, Tunisia, North Africa. Feldwebel Ernst Hoffman pressed himself against the cold limestone outcrop as American rifle fire cracked overhead. The sound was wrong, not the familiar rhythm of bolt-action rifles he had heard across Poland, France, and Russia, but something continuous, relentless, impossibly sustained. He risked a glance over the rocks. Across the scrubland, perhaps 80 meters distant, American infantrymen advanced in a loose skirmish line. Hoffman raised his Karabiner 98K, acquired his target, fired. The American dropped. Hoffman worked the bolt, ejecting the spent cartridge, chambering a fresh round. Before he could acquire his next target, 3 Americans had already returned fire, not once, but multiple times each. 8 shots, 9 shots, continuous aimed fire without pause. His training told him this was impossible. Infantry rifles required manual operation between shots. You fired, you worked the action, you fired again. That was the rhythm of infantry combat, unchanged since smokeless powder replaced black powder 50 years earlier. Yet these Americans were firing as fast as they could pull their triggers, and they were hitting what they aimed at. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. By nightfall, Hoffman's company had withdrawn from Longstop Hill, leaving behind 17 dead and 23 wounded. Among the equipment they abandoned in their hasty retreat was 1 American rifle, dropped by a wounded soldier and missed during the American recovery of their casualties. That rifle, serial number USA 1385847, manufactured by Springfield Armory in Massachusetts, would reach German testing facilities within 3 weeks. What German weapons analysts discovered when they examined this captured M1 Garand would force a complete reassessment of American military capabilities and expose catastrophic failures in German small arms development that could never be corrected before war's end. The rifle represented not just technological advantage, but industrial maturity and engineering philosophy that Germany fundamentally lacked, despite its scientific expertise and manufacturing sophistication. The confidence of German infantry in 1942 rested on proven battlefield success and superior equipment doctrine. The Karabiner 98K, adopted June 21, 1935, embodied everything German military thinking valued in an infantry rifle. Accurate to 500 meters with iron sights, reliable in extremes of temperature and battlefield conditions, simple enough for conscripts to maintain with minimal tools, the Kar-98K had armed German soldiers through victories across Europe. It fired the powerful 7.92mm by 57mm Mauser cartridge, capable of penetrating substantial per se cover and defeating body armor at combat ranges. The rifle's bolt-action mechanism, refined through decades of development from the original Gewehr 98 adopted in 1898, represented the pinnacle of manually operated rifle design. In trained hands, a German soldier could fire 15 carefully aimed rounds per minute, working the bolt with practiced efficiency between each shot. German infantry doctrine emphasized fire discipline and accurate shooting from prepared positions. Training manuals stressed that every cartridge must be deliberately placed, that volume of fire meant nothing without precision. This philosophy had proven effective against Polish forces, armed with Mauser pattern rifles, French troops carrying the Lebel and Berthier, and British soldiers using the Lee Enfield. All of these were bolt-action weapons requiring manual operation between shots. When German intelligence assessed American military equipment in 1941 and early 1942, their reports reflected confidence bordering on dismissiveness. American industry, the assessments acknowledged, could produce vast quantities of equipment, but quantity, German analysts insisted, could not compensate for inferior quality and inadequate tactical doctrine. The M1 Garand appeared in these intelligence summaries as a semi-automatic rifle of technical interest but limited military significance. German weapons experts noted its self-loading mechanism and 8-round capacity, but emphasized what they considered critical flaws. The rifle weighed 9.5 pounds compared to the Kar 98K's 8.2 pounds. It was longer, more complex, required more maintenance, and used an unusual En-bloc clip system that German analysts considered unnecessarily complicated compared to simple stripper clips. Most critically, German assessments concluded that semi-automatic operation necessarily sacrificed the accuracy and reliability essential for military rifles. The moving parts required for self-loading operation, the reports stated, introduced variables that degraded precision. The mechanical complexity would prove fragile under field conditions. American soldiers, inadequately trained and inexperienced, would struggle to maintain these sophisticated weapons properly. These assessments were fundamentally, catastrophically wrong. By December 1942, when Hoffman's unit encountered sustained American rifle fire at Longstop Hill, the M1 Garand had already proven itself through a full year of brutal combat. American forces in the Philippines had used M1 rifles against Japanese infantry beginning December 8, 1941. Reports from those desperate battles consistently mentioned Japanese confusion about American firepower, with enemy commanders reportedly believing they faced machine gun fire rather than rifle fire. General Douglas MacArthur, commanding American and Filipino forces during the defense of Bataan, specifically praised the M1 Garand's performance in cables to the War Department. In one February 1942 communication, he noted that the rifle had functioned flawlessly, despite dust, humidity, and the filth of foxhole fighting. Soldiers with minimal maintenance facilities kept their rifles operating through weeks of continuous combat. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now, back to the story. The rifle recovered near Longstop Hill arrived at the Heereswaffenamt, the German Army Weapons Office testing facility at Kummersdorf, 25 kilometers south of Berlin, on January 7, 1943. It bore obvious signs of combat use with worn finish on high contact areas and minor dents in the stock, but remained mechanically sound and fully functional. German weapons engineers approached the examination with systematic thoroughness. They photographed every component from multiple angles, measured dimensions with precision instruments, documented construction techniques and materials with exhaustive detail. What they discovered in the first hours of examination contradicted nearly every assumption German intelligence had made about American weapons manufacturing. The rifle's construction demonstrated manufacturing sophistication that German analysts had not credited to American industry. Tolerances were generous by German precision standards, yet components fit together perfectly with no binding or excessive play. The gas system, which German designers had considered too complex for field reliability, consisted of only a few parts machined to standards that allowed easy disassembly and cleaning without special tools. The operating rod, the component that cycled the action using gas pressure from fired cartridges, showed wear patterns indicating thousands of rounds fired, yet maintained perfect function. German engineers had expected to find a mechanism worn, nearly to failure after combat use. Instead, they found a design with such substantial safety margins that normal wear had not degraded performance. The trigger mechanism revealed American manufacturing philosophy that German engineers found both impressive and frustrating. Where German weapons used precisely fitted parts requiring skilled hand-fitting during assembly, the M1 Garand used components manufactured to tolerances that allowed complete interchangeability. Any trigger group would fit any receiver without adjustment. Any operating rod would function in any rifle without modification. This level of standardization, routine in American automotive manufacturing since the 1920s, remained largely theoretical in German weapons production. German manufacturers introduced subtle variations in their components that prevented true interchangeability between rifles from different production lots, much less different factories. Field armorers opening spare parts containers never knew if a replacement component would require hand-fitting before installation. The American rifle disassembled without tools in under 30 seconds. The operating rod could be removed by pulling the trigger guard forward, rotating it down, and withdrawing the rod and bolt from the receiver. No screws required removal, no pins needed to be driven out. Reassembly took equally little time and required no special knowledge beyond the basic procedure. German engineers, testing the procedure with no prior instructions successfully, field-stripped and reassembled the rifle in under 2 minutes on their first attempt. By comparison, proper disassembly of the Kar-98K required removing multiple screws, careful tracking of small parts, and attention to correct reassembly sequence to avoid damaging components. The testing program began with basic function trials. Engineers loaded the rifle with captured American .30-06 ammunition taken from supply dumps during the Tunisia fighting. The first shot surprised them with its moderate recoil despite firing a cartridge more powerful than the standard German 7.92mm round. The rifle cycled smoothly, ejecting the spent case and chambering a fresh round with mechanical efficiency that seemed effortless. They fired slowly at first, allowing the barrel to cool between shots, measuring accuracy from a bench rest at 100 meters. Groups measured 3 to 4 inches, accuracy equivalent to or better than standard production Kar-98K rifles. This contradicted German assumptions that semi-automatic operation degraded precision. The rifle maintained perfect sight alignment between shots because the barrel never moved, and the sights remained undisturbed during the cycling process. Rapid-fire testing revealed the weapon's true capability. An engineer, not a trained infantry soldier but a civilian technician with basic familiarity with military rifles, fired 8 rounds in 12 seconds, hitting a man-sized target at 100 meters with 6 of 8 shots. He reloaded with a fresh en-bloc clip and repeated the exercise, this time landing 7 of 8 rounds on target in 11 seconds. The implications were immediately obvious to everyone present. A marginally trained shooter could deliver accurate fire at a rate approaching 40 rounds per minute. A properly trained infantry soldier could likely exceed that rate while maintaining hit probability. By comparison, the same technician firing a Kar-98K achieved only 18 rounds per minute, and his accuracy degraded significantly as he tired from working the bolt repeatedly. The mathematics of infantry firepower had fundamentally changed, and German weapons engineers knew it. One American rifleman possessed firepower equivalent to 2 or 3 German riflemen, not through superior marksmanship or tactical skill, but through equipment that simply worked faster without sacrificing accuracy. The technical examination expanded to encompass every aspect of the rifle's design and function. Engineers at Kummersdorf operated under explicit orders from the Heereswaffenamt to determine precisely how the Americans had achieved reliable semi-automatic operation and whether German industry could replicate or counter this. Advantage. The gas system received particular scrutiny. German designers had long debated the merits of gas-operated versus other semi-automatic mechanisms. The prevailing German view held that drilling a port in the barrel to bleed off propellant gases would cause premature erosion and accuracy degradation. This concern had driven German engineers toward complex gas trap systems that captured gases at the muzzle without compromising barrel integrity. The M1 Garand used a simple mid-barrel gas port located approximately 7 inches behind the muzzle. Propellant gases bled through this port into a cylinder beneath the barrel, driving a piston that cycled the action. German engineers examined the gas port and surrounding barrel with magnification, searching for the erosion patterns they expected to find. The erosion was minimal, far less than German theory predicted. The barrel showed normal wear from firing, but no accelerated degradation around the gas port. Years later, post-war testing would demonstrate that properly maintained M1 Garand barrels lasted for 10,000 rounds or more, before accuracy degraded below acceptable standards. The gas port contributed negligibly to barrel wear. This single observation undermined years of German small arms development doctrine. The complexity German designers had accepted as necessary to avoid gas port problems proved unnecessary. American engineers had simply drilled a hole in the barrel, sized it correctly, and the system worked with complete reliability. The bolt mechanism demonstrated similar practical engineering excellence. The rotating bolt locked into the receiver with multiple lugs, distributing firing stresses across a large surface area. The geometry ensured that the bolt could not unlock until chamber pressure dropped to safe levels. The entire locking sequence occurred automatically, requiring no conscious thought from the shooter. German engineers noted that the bolt showed wear patterns consistent with thousands of firing cycles, yet maintained perfect function. The locking surfaces, despite obvious use, still engaged fully with no signs of battering or deformation. The steel specifications and heat treatment produced components with wear resistance that exceeded anything required for the rifle's expected service life. The trigger mechanism incorporated a hammer-fired system that provided consistent trigger pull and positive ignition. The design included a disconnector that prevented the rifle from firing in full automatic mode, ensuring each trigger pull produced exactly one shot. This represented deliberate engineering choice rather than limitation. American designers understood that controllable semi-automatic fire provided optimal balance between rate of fire and accuracy for infantry rifles. German weapons engineers preparing their technical report faced uncomfortable conclusions. The M1 Garand was not a flawed design that sacrificed reliability for rate of fire. It was a mature, well-engineered weapon that achieved sustained automatic operation without compromising accuracy, reliability, or durability. Every component showed design margins that exceeded immediate requirements, providing longevity and tolerance for abuse that German rifles could not match. The En-bloc clip system, initially dismissed as unnecessarily complicated, revealed unexpected advantages upon detailed examination. The 8-round clip inserted directly into the rifle's internal magazine, held in place by the magazine follower. When loaded, the clip became part of the rifle's mechanism, feeding cartridges upward as the action cycled. After the last round fired, the empty clip automatically ejected upward through the action with a distinctive metallic ping. German analysts noted this sound might alert enemies to an empty rifle, but combat reports from American soldiers indicated that battlefield noise made the ping inaudible beyond a few meters. The En-bloc system provided several practical advantages. The clip protected cartridges from damage during loading and storage. The fixed 8-round capacity eliminated feeding problems that plagued rifles using detachable magazines with varying spring tensions. The simplicity meant nothing could be assembled incorrectly, and soldiers could load their rifles quickly, even in darkness or under stress. By comparison, the Kar 98K used stripper clips holding 5 rounds that had to be pushed down into the internal magazine against spring pressure. This required care and strength, particularly with cold hands or wearing gloves. The process took several seconds and demanded attention, making soldiers vulnerable while reloading. The M1 Garand's En-bloc clip snapped into place in under 2 seconds with minimal effort. Reliability testing subjected the captured rifle to conditions designed to induce failures. Engineers fired hundreds of rounds without cleaning, allowing powder residue and carbon buildup to accumulate in the action. The rifle continued functioning normally. They fired in sub-freezing temperatures after leaving the rifle exposed overnight in an unheated building. The rifle functioned without hesitation despite cold-thickened lubricants. They deliberately fouled the action by firing the rifle, then immediately submerging it in muddy water before firing again. The M1 Garand continued cycling, though with slightly reduced reliability. After basic field cleaning with only a cloth and bore brush, reliability returned to normal. This abuse would have rendered most German weapons inoperable without detailed disassembly and thorough cleaning by trained armourers. The testing program expanded to include endurance, trials measuring component life under sustained use. Engineers fired 5,000 rounds through the rifle over several weeks, cleaning it according to American field manual procedures after every 200 rounds. At completion, they disassembled the weapon and measured critical dimensions on every component, comparing them to measurements taken before the endurance trial began. Wear was measurable, but minimal. The bore showed slight erosion but remained well within acceptable accuracy standards. The gas piston had worn slightly but functioned perfectly. The bolt lugs showed polishing from repeated locking and unlocking but no deformation. The extractor and ejector showed no wear at all, despite thousands of cycles. Every component remained serviceable, and the rifle would have continued functioning through thousands of additional rounds. German weapons engineers calculated that properly maintained M1 Garands could fire 20,000 rounds before requiring major component replacement. By comparison, the Kar-98K, though simpler in design, required bolt component replacement after approximately 15,000 rounds due to locking lug wear. The more complex American rifle actually outlasted the simpler German design through superior materials and more generous engineering margins. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The report, prepared by Kummersdorf engineers, dated March 15, 1943, documented findings with scientific precision and professional objectivity. The conclusions, however, carried implications that went far beyond technical specifications. The document stated clearly that the M1 Garand represented a significant technological advantage for American infantry, providing individual soldiers with firepower approaching that of German light machine gun teams. The report noted that American manufacturing techniques demonstrated industrial maturity that German industry had not achieved in small arms production. Component interchangeability, generous tolerances that still produced reliable function, and design margins that prioritized longevity and field reliability over theoretical optimization all reflected decades of American automotive and agricultural machinery manufacturing experience applied to military weapons. Most critically, the report acknowledged that Germany possessed no equivalent weapon in service or development that could counter this American advantage. The document recommended immediate priority development of German semi-automatic rifles, but the engineers who wrote those recommendations understood the recommendation came too late. Germany was already 2 years into a war being fought on multiple fronts. Retooling production, training workers, and fielding new weapons in quantities sufficient to matter would require years Germany no longer had. Copies of the Kummersdorf report circulated through Wehrmacht technical branches and reached senior officers responsible for infantry equipment and doctrine. The response revealed institutional resistance to uncomfortable truths. Some officers questioned whether the test results truly reflected field conditions, suggesting that American rifles might function well in laboratory settings but fail under combat stress. Others argued that German infantry training and tactical superiority would compensate for any equipment disadvantages. A few acknowledged the problem but pointed out that Germany lacked industrial capacity to replace millions of Kar-98K rifles while simultaneously maintaining production of machine guns, artillery, tanks, and aircraft. The brutal reality was that Germany had entered the war without an effective semi-automatic infantry rifle and possessed no viable path to fielding one before war's end. German semi-automatic rifle development had begun years before the war but followed problematic paths. The Gewehr 41, Germany's first serious attempt at a self-loading infantry rifle, emerged from competing designs by Mauser and Walther, submitted in 1941. Both designs suffered from fundamental flaws rooted in German specifications that forbade drilling gas ports in barrels. Without gas ports, German engineers developed complex gas trap systems that captured propellant gases at the muzzle and redirected them to operate the action. These mechanisms added weight, created reliability problems, and fouled rapidly under field conditions. The Gewehr 41 Mauser and Gewehr 41 Walther both saw limited field trials, and both failed spectacularly. Soldiers reported that the rifles jammed frequently, required constant maintenance, and proved so unreliable that troops refused to carry them in combat, preferring their dependable Kar-98K rifles. Production totaled perhaps 10,000 to 15,000 rifles before the program was abandoned as hopeless. The few G41 rifles that reached combat units were quickly relegated to rear area duties or simply discarded. The failure forced German engineers to reconsider their assumptions. Captured Soviet SVT-40 rifles demonstrated that gas port systems, properly designed, provided reliable automatic operation. German stubbornness about avoiding barrel ports had wasted years and produced nothing usable. The Gewehr 43, introduced in October 1943, incorporated lessons learned from captured Soviet weapons and represented Germany's first successful semi-automatic rifle. The G43 used a simpler gas system with a proper gas port, featured a detachable 10-round magazine, and weighed less than the failed G41 designs. Soldiers who received the weapon appreciated its capabilities, and it functioned reliably under field conditions. Production reached approximately 42,000 rifles by war's end, with an additional 53,000 fitted with telescopic sights for use by designated marksmen. These numbers represented complete failure to address the problem identified by Kummersdorf testing. Germany was producing hundreds of thousands of Kar 98K rifles monthly, while G43 production barely reached a few thousand per month. For every 50 bolt-action rifles entering service, perhaps one semi-automatic rifle became available. The vast majority of German infantry continued carrying Kar 98K rifles until the war ended. Even soldiers fortunate enough to receive G43 rifles found them inferior to the M1 Garand in crucial aspects. The German rifle, while functional, required more maintenance, proved more sensitive to ammunition quality variations, and suffered from parts availability problems as German industry strained under Allied bombing and resource shortages. The detachable magazine, seemingly an advantage over the M1's en-bloc clip system, proved problematic as magazines were frequently lost, damaged, or worn out without adequate replacements reaching field units. The fundamental problem remained that Germany had squandered years on failed gas trap designs, while the United States armed its entire military with proven semi-automatic rifles. By the time Germany fielded a workable semi-automatic rifle, American soldiers had been carrying M1 Garands for years, had developed effective tactics around the weapon's capabilities, and had achieved proficiency through extensive combat experience. Combat reports from German units facing American infantry consistently noted the firepower disparity. A captured German document from the 352nd Infantry Division, which defended Omaha Beach during the Normandy invasion on June 6, 1944, specifically mentioned overwhelming American rifle fire that prevented German soldiers from maintaining effective return fire. The report stated that American infantry could generate sustained fire that pinned down German defenders, even when Germans held superior positions with excellent cover. Machine gun crews found themselves targeted by dozens of rifles simultaneously, making it impossible to serve their weapons effectively. The defensive battle that should have been decided by German machine guns and prepared positions instead became a firefight decided by individual rifle effectiveness, a contest Germans could not win. Statistical analysis prepared by Wehrmacht operational research units in late 1944 examined casualty data from engagements across multiple theaters. The findings confirmed what field commanders already knew from bitter experience. In small unit actions at ranges under 200 meters, American infantry squads inflicted casualties at rates significantly exceeding German infantry squads of equivalent size. While many factors contributed to this disparity, including American artillery support and tactical air superiority, the consistent pattern across diverse combat situations pointed clearly toward American advantages in individual infantry weapons. German soldiers armed with bolt-action rifles could not match the firepower of Americans armed with semi-automatic rifles, even when German soldiers possessed superior tactical positions and greater combat experience. The German army's response to American rifle superiority evolved through desperation rather than planning. By mid-1943, Wehrmacht leadership understood they faced systematic firepower disadvantage at the squad level, the most fundamental building block of infantry combat. The solutions they pursued revealed how completely American industrial capacity and engineering maturity had outpaced German capabilities. Traditional German infantry doctrine relied on squad organization built around the machine gun. The MG-34, and later the MG-42, served as the squad's primary weapon, with riflemen providing security and support for the machine gun team. This doctrine worked effectively when all sides employed similar bolt-action rifles, and victory depended on which side could bring superior machine gun fire to bear. American infantry organization, by contrast, distributed firepower across the entire squad. Every rifleman carried a weapon capable of sustained rapid fire. The Browning automatic rifle provided additional firepower, but unlike German squads where riflemen existed primarily to support the machine gun, American squads functioned as 8 or 9 individually powerful firing units that could engage targets simultaneously. The tactical implications became clear in combat across every theatre. German squads required their machine gun to suppress enemies while riflemen maneuvered. If the machine gun was destroyed or suppressed, the squad's combat power collapsed dramatically. American squads maintained substantial combat power even after losing their BAR gunner because every rifleman could still deliver effective fire. German defensive positions that would have stopped rifle-armed infantry found themselves overwhelmed by volume of fire from M1 Garands. Attackers advancing under covering fire from their squad mates received such sustained suppression that defenders could not effectively return fire. The mathematics remained constant across thousands of engagements. 8 Americans with Garands could generate more rifle fire than 12 Germans with Kar 98Ks, and that fire would be more accurate because American soldiers never broke their sight picture to work a bolt. Field Marshal Erwin Rommel, commanding German forces in North Africa until March 1943, noted in reports to the Oberkommando der Wehrmacht that American infantry demonstrated surprising effectiveness despite their lack of combat experience. His assessment attributed much of this effectiveness to superior equipment, specifically mentioning American rifle fire as unusually heavy and sustained. Rommel, unlike some German commanders, understood that equipment advantages could not be dismissed as unimportant compared to training and doctrine. An adequately trained soldier with superior equipment would defeat a superbly trained soldier with inferior equipment, particularly when the equipment advantage was as substantial as the M1 Garand represented. The German response took form in the Sturmgewehr 44, the world's first true assault rifle. Development had begun years earlier as the Maschinen Karabiner 42, but the weapon didn't reach production until 1944. The St. G44 fired a shortened cartridge, the 7.92mm by 33mm Kurz, from a 30-round detachable magazine in either semi-automatic or full-automatic modes. The rifle represented revolutionary thinking about infantry weapons. German combat experience on the Eastern Front demonstrated that most infantry engagements occurred within 300 meters, making the Kar 98K's effective range of 800 meters unnecessarily excessive. A rifle optimized for typical combat ranges could use less powerful ammunition, reducing recoil and allowing controllable automatic fire. The concept was sound, and the St. G44 performed well in combat. Soldiers who received the weapon praised its effectiveness. Production reached approximately 426,000 rifles by war's end, impressive for a completely new weapon introduced during Germany's industrial collapse. But 426,000 rifles spread across the entire Wehrmacht represented a fraction of what was needed. Most German infantry never saw a Sturmgewehr 44. Those fortunate enough to receive the weapon often lacked adequate ammunition, as Germany's industrial capacity crumbled under Allied strategic bombing and loss of occupied territories. The St. G44, like the G43 before it, arrived too late and in insufficient numbers to change outcomes that had already been decided by earlier equipment failures. By comparison, American industry produced over 4 million M1 Garand rifles between 1937 and 1945. Springfield Armory in Massachusetts manufactured approximately 3,527,000 rifles. Winchester Repeating Arms in Connecticut produced 513,880 rifles. Production reached such levels that by D-Day, June 6, 1944, virtually every American rifleman in Europe carried an M1 Garand. This represented achievement unprecedented in military history. An entire armed force, numbering in the millions, operating across multiple theaters on several continents, uniformly equipped with semi-automatic rifles, while opponents still relied primarily on bolt-action weapons. The industrial capacity required to accomplish this, while simultaneously producing aircraft, ships, tanks, artillery, and every other weapon of modern war demonstrated American economic power that no other nation could match. The M1 Garand's development history revealed the planning and investment that made this achievement possible. John Cantius Garand, born January 1, 1888, in Saint-Rémy, Quebec, Canada, immigrated to the United States with his family in 1899. He began working at Springfield Armory on November 4, 1919, devoting nearly 2 decades to perfecting his semi-automatic rifle design. Early prototypes used different operating systems and calibers. The United States Army initially favored a smaller 276 caliber cartridge, offering improved ballistics compared to 30-06. But General Douglas MacArthur, serving as Army Chief of Staff, insisted on retaining 30-06 to utilize existing ammunition stocks and maintain compatibility with machine guns using the same cartridge. This decision, made in 1932, delayed adoption by several years but ultimately proved strategically sound. Garand continued refining his design through the early 1930s. The rifle underwent exhaustive testing at Aberdeen Proving Ground in Maryland and Springfield Armory in Massachusetts. Problems were systematically identified and corrected through iterative design improvements. The gas system evolved from an early gas trap design to the simpler and more reliable gas port system. The trigger mechanism was refined for consistent pull weight and positive engagement. The stock design was improved for better ergonomics and reduced felt recoil. On January 9, 1936, the rifle was officially adopted as United States Rifle, caliber .30, M1. Initial production proceeded slowly, with only a few thousand rifles manufactured in 1937 and 1938, as production methods were refined and workforce training completed. Production accelerated dramatically as war loomed, reaching 600 rifles per day by January 1941, months before American entry into the war. This timeline meant that when the United States entered World War II, in December 1941, substantial numbers of M1 Garand rifles already existed in inventory, and production capacity was established to manufacture thousands more monthly. American forces deploying to combat carried proven weapons that had been thoroughly tested and refined over years of peacetime development. Germany, by contrast, entered the war in September 1939 with bolt-action rifles essentially unchanged from the previous war and no viable semi-automatic rifle program. The Reich squandered the war's early years on failed gas trap designs, while American soldiers were already carrying M1 Garands in combat. This head start proved impossible to overcome once Germany found itself fighting on multiple fronts against enemies with superior resources. The human cost of Germany's small arms development failure appeared in casualty statistics and after-action reports from across all theaters. American infantry consistently won firefights, even when outnumbered, attacking fortified positions, provided they had reasonable cover and adequate ammunition. The M1 Garand's firepower advantage translated directly into German casualties. Individual engagements told the story in microcosm. At Anzio, Italy, during fighting in February 1944, American forces defending against German counterattacks generated such heavy rifle fire that German infantry could not close with American positions despite numerical superiority and aggressive tactics. German commanders reported that American defensive fire exceeded anything they had experienced on the Eastern Front, where Soviet infantry primarily carried bolt-action Mosin Nagant rifles. In the Hurtgen Forest, during October and November 1944, German troops defending in heavily forested terrain that should have negated American advantages in artillery and air power still found themselves outmatched in close-range firefights. The dense forest limited visibility to 50 meters or less, ranges where rapid-fire capability mattered more than long-range accuracy. American soldiers could engage targets as quickly as they appeared, while German soldiers had to work their bolt between shots, a fatal hesitation in sudden close-quarters encounters. The Battle of the Bulge, Germany's last major offensive in the West beginning December 16, 1944, demonstrated how firepower disparity affected offensive operations. German infantry attacking American positions encountered rifle fire that decimated assault formations. Units that achieved surprise and overran American positions in the initial assault found themselves unable to exploit success because subsequent waves of infantry were stopped by devastating defensive fire from surviving American units. German soldiers who survived the offensive and were later interviewed by Allied intelligence officers consistently mentioned American rifle fire as unexpectedly heavy. Many stated they believed they faced machine gun fire until they observed American soldiers with rifles. The psychological impact of facing sustained, accurate fire from individual riflemen affected German morale and tactical confidence. Post-war studies by United States Army historical researchers examined small unit action reports from 1943 through 1945, analyzing thousands of engagements across all theaters. The data revealed that American infantry squads inflicted casualties at rates approximately 50% higher than equivalent German infantry squads when comparing engagements at similar ranges with similar terrain and tactical situations. While multiple factors contributed to this advantage, including American artillery support and close air support, the consistent pattern across diverse combat situations demonstrated that American infantry possessed fundamental advantages in individual weapons effectiveness. The M1 Garand accounted for substantial portions of this advantage through its superior rate of accurate fire. German attempts to compensate through superior tactics and positioning achieved only limited success. Well-trained German infantry using terrain effectively could mitigate some of the American firepower advantage, but even veteran troops could not entirely overcome the mathematical reality that they were being outshot by opponents with better rifles. The Eastern Front provided additional context for understanding the M1 Garand's impact. Soviet forces received over 4,000 M4A, 2 Sherman tanks through Lend-Lease but received relatively few M1 Garand rifles as the Soviet Union prioritized submachine guns for close-quarters fighting. However, some Soviet units did receive Garands, and German troops who encountered them reported similar experiences to those facing American forces, noting sustained rifle fire that seemed impossible from bolt-action weapons. The distribution of M1 Garands extended beyond United States forces. The rifle served with Free French forces, Italian co-belligerent units after Italy's September 1943 surrender, and Chinese forces in the China-Burma-India theater. Every theater where M1 Garand saw combat confirmed the weapon's superiority over bolt-action rifles through demonstrated battlefield effectiveness. The M1 Garand's influence extended beyond World War II into subsequent conflicts and weapons development. The rifle remained the United States military's standard infantry weapon through the Korean War, where it again proved its worth in sustained combat. American soldiers armed with M1 Garands consistently outfought North Korean and Chinese forces armed with bolt-action rifles and submachine guns. The rifle was not officially replaced as standard service weapon until the M14 was adopted in 1957, with first deliveries to troops beginning July 1959. Full transition across all units required until 1961. Even then, M1 Garands remained in service, with Reserve and National Guard units into the 1970s. The rifle's 20-year frontline service life and subsequent reserve service demonstrated durability and effectiveness that few military weapons achieve. The principle the M1 Garand established, that infantry benefit from self-loading rifles providing increased rate of fire without sacrificing accuracy, became foundational to all subsequent military rifle development. Every modern infantry rifle, from the Soviet AK-47 to the American M16 to current assault rifles, owes conceptual debt to the M1 Garand's demonstration that semi-automatic operation was not just feasible but essential for military rifles. German post-war small arms development, both in West Germany and East Germany, explicitly incorporated lessons learned from facing American M1 Garands in combat. The Bundeswehr's G3 rifle and subsequent weapons emphasized reliability and sustained fire capability over theoretical performance specifications. East German weapons programs similarly prioritized practical effectiveness over engineering optimization. The story of German weapons engineers testing the captured M1 Garand at Kummersdorf represents a moment when technological superiority met institutional resistance and demonstrated that recognition of problems does not guarantee solutions. German engineers correctly identified American advantages, accurately assessed the threat, and properly recommended responses. But recommendations require industrial capacity, time, and resources to implement, commodities Germany lacked by 1943. The captured rifle, serial number USA 1385847, remained at Kummersdorf through 1943 and into 1944, used for additional testing and as a reference standard for German semi-automatic rifle development programs. Its location, after Soviet forces captured Kummersdorf in April 1945, remains unknown. Perhaps it was destroyed during the fighting, perhaps captured, again by Soviet forces and lost among millions of pieces of captured equipment. Perhaps it survived and sits unrecognized in a collection somewhere. The rifle's physical fate matters less than what it represented. One mass-produced American rifle among millions, distinguished only by the circumstances of its capture and the thoroughness with which German engineers examined it. The testing revealed truths German military leadership did not want to acknowledge about American industrial capability and their own failures in weapons development. Those truths could not be disputed because the evidence was mechanical, measurable, and undeniable. The M1 Garand fired 40 rounds per minute accurately. The Kar 98K fired 15 rounds per minute. No amount of training, tactical doctrine, or ideological conviction could overcome that 3-to-1 firepower advantage repeated across millions of soldiers in thousands of engagements. General George S. Patton's famous assessment in a letter dated January 26, 1945, to Major General Levin H. Campbell, Jr., Chief of Ordnance, declared the M1 Garand the greatest battle implement ever devised. German soldiers who faced it in combat would not have disagreed with that assessment, though they learned its superiority through bitter experience rather than appreciation of friendly equipment. The rifle gave American infantry a decisive tactical advantage in the most fundamental military task, hitting the enemy before the enemy hits you. In that task, the M1 Garand excelled beyond any contemporary weapon. Its reliability ensured it functioned when needed. Its accuracy ensured rounds hit their targets. Its rate of fire ensured American soldiers could engage multiple targets or deliver sustained fire on single targets with effectiveness bolt-action rifles could never match. From the Philippines to North Africa, from Sicily to Normandy, from the hedgerows to the Rhine, from Iwo Jima to Okinawa, the M1 Garand served, faithfully and effectively. It earned its reputation through performance in every climate and terrain where warfare occurred. It proved itself against every enemy America fought. It demonstrated that superior equipment, properly designed and manufactured at scale, provides advantages that training and doctrine cannot overcome. German infantry, brave and well-trained as they were, fought with equipment that placed them at disadvantage in the most critical infantry task. They learned through combat that courage and skill cannot compensate for being outgunned by opponents with weapons that fire 3 times faster while maintaining equal accuracy. They faced that disadvantage in every engagement from their first encounters with American forces until war's end, knowing that their own military had failed to provide equivalent equipment. The M1 Garand demonstrated that the future of infantry combat belonged to self-loading rifles. The age of bolt-action rifles ended not through theoretical debate or doctrinal discussion, but through battlefield demonstration that soldiers armed with semi-automatic weapons would consistently defeat soldiers armed with bolt-action rifles. German engineers understood this by March 1943 when they completed their testing at Kummersdorf. German soldiers learned it through desperate experience in combat. German leadership never successfully responded to the challenge. In final analysis, the M1 Garand's impact on World War II extended far beyond its technical specifications. The rifle represented American industrial foresight in recognizing that future conflicts would require superior individual weapons, engineering excellence in creating a design that worked reliably under all conditions, and industrial capacity to manufacture millions of rifles, while simultaneously producing every other weapon modern war required. Germany possessed scientific knowledge and engineering expertise equal to or exceeding American capabilities in many areas. What Germany lacked was the industrial maturity, manufacturing sophistication, and decades of civilian mass production experience that American industry applied to military manufacturing. The M1 Garand emerged from that industrial base, and no amount of German engineering brilliance could overcome that fundamental economic disparity. The rifle didn't win the war alone. Victory required combined arms operations, overwhelming air superiority, industrial production that buried enemies under avalanches of equipment, and courage of millions of soldiers, sailors, airmen, and marines. But at the squad level where soldiers actually fought and died, the M1 Garand provided clear and measurable advantage that German infantry could not effectively counter despite their training, experience, and tactical skill. That advantage made the difference in countless engagements, saved American lives, helped bring the war to swifter conclusion than might otherwise have occurred, and established principles that guided military rifle development for decades afterward. The M1 Garand stands as testament to what properly designed military equipment can achieve when industrial capacity, engineering excellence, and strategic planning combine to provide soldiers with the best possible tools. For German weapons engineers who tested the captured rifle at Kummersdorf, their findings represented professional duty faithfully executed. They identified the problem, documented the evidence, and recommended solutions. That their recommendations came too late, and Germany lacked capacity to implement them, reflected failures at levels far above their authority. The engineers did their job correctly. Their leadership had already lost the industrial war that would decide all others. Up next, you've got two more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.